calculator on your screen, right? So I think this is a little bit cleaner and easier, right? And I believe, oh, shooting space, go over here, right? Are you still looking at it now that I've moved it? Right. So it was getting in the way of one of my other windows. So I'm going to go view and I'm going to do key press. Do you also get to see a little window called key press next to it? Right. So let's suppose I want to use my calculator to get 5-figure summaries like you were talking about, Cody. Okay. So we would start off by hitting the start button. So I'm going to record this video. So if you don't need to frantically write it down, you can just go back, you know, and pause it, especially if I hit lots of buttons.
But this is for 5-figure summary?
Yeah, 5-figure summary. So you hit the start button and number 1 is the option I want, edit. So I just press enter. And then I type the data in. Isn't this a cool calculator, right? So I'm just making up random numbers, right? Till you get bored, right? You'd put in whatever the real data was. So far, so good. Now, once you've done all of that, you then hit start button again. And you want to move over to the calc menu. So you hit this little cursor guy once and you choose option 1 and you press enter. Right. And you see how my calculator has already got L1 by default, right? Most of the time, that's what yours is going to have. If for some reason, you know, your little kid started hitting buttons and move things around, if you had to type it from scratch, you would get it from down here. You see that number 1 in blue above it? So you just hit blue button L1, right? If it's already there, just hit enter. And now enter, enter, enter. And here is your 5-figure summary. In fact, more than your 5-figure summary, here's everything. So for instance, the mean of all those numbers I typed in is 18.3.
Okay, go out there, please.
See that? 18.3. There are 2 standard deviations here. The one that you're always going to pick, at least in the questions you're going to see from me, is this one here. Do you see the 27.2 guy? That's the standard deviation, right? That one there. That other one you can forget.
We're not going to be doing the EX or the EX squared or?
Nah, nobody needs to know them. It tells you more than you need, right? It tells you lots of things you don't need to even worry about. I mean, if you wanted to know, see that little, that's sigma, that's a Greek letter sigma. Sigma X just said, look, if you added all those numbers up, it'd be 275. I guess if you wanted to know that, now you know it, right? But we don't.
And then XX is standard deviation?
Yeah, SX is standard deviation, correct?
What's the one underneath it?
If you don't need to know it, use it. But if you want to, it's a population standard deviation. So if you imagine you did a census, in which case the standard deviation is calculated a little bit differently when it's everybody. Oh, I just went. I don't know why, it just went weird color. Now, if we hit this little button here, oh, it even has that save energy on the screen mode. That is really fascinating. Right, if I scroll this a little bit up, here is your 5-figure summary and other numbers. 15 numbers and the 5-figure summary now. 4, 5, 6, 23, and 89. Do you see the numbers that would be the 5-figure summary, these last 5 numbers? They're all there. In fact, isn't that the thing that you would use if you wanted to do a box plot, right? 5-figure summary. I think that's it. I'm trying to think of anything else. Anything else you need to know? You feel comfortable about the button pressing then?
Yeah.
Right. And as I said, this is going to be put on our canvas, so you can go and have a quick look at it. It's only going to be in the first 5 minutes, right? So you don't need to look through everything after that unless you want to. How are we doing, guys? Right. Next person, give me a question, somebody. Or a topic, or whatever you want.
Can we do question 20 on the practice final?
Sure. Take a few minutes to find it, but that's not a big deal. Question 20 on the final. Let's move this over here so I can see it better. 146. Practice final. There we go. And 26, you said. I'll scroll down to 20.
Question 20.
Oh, question
20.
2020.
Mhm.
I don't have it. Was it multiple choice 20?
Yep.
Okay. So let me just show you the question, then I'll look at how we would solve it. So you are there. Now, this question isn't a calculation question, and this question is just a logic question, right? An intuitive thing. So bear that in mind. Now, a coin is going to be tossed either 10 times, or it's going to be tossed 100 times, or it's going to be thrown 1,000 times. And you get to win $10 if the total number of heads that you end up with is between 5 and 10 heads, right? So if you threw it 100 times, if the final result is there was somewhere between 5 and 10 heads, you win your money, right? If you do it 1,000 times, if you do it. So that's the gist of the story. So now I'm going to try and explain why your best chance of winning is when you do it 10 times. If you imagine a number line from 0 to 10, right? So you threw it 10 times, and right in the middle is 5. All of that is a winning region. Would you agree that's like half the shape? Now, if you do, I'll have to change the scale here. If you do it can you see that your winning region is a lot smaller when you do it 100 times? So isn't that kind of reflecting it's less likely to be true? Now, I'm not doing the 1,001, but if I did do the 1,001, would it be like a little full stop? There'd be almost no chance of that happening, right? It'd be very hard. So that's the answer. Do it 10. Do the one where you only throw it 10 times. Because won't you win half the time? If you do it 100.
Okay, thank you.
Yeah, is that the logic enough? Make sense? That's, yeah, some questions are like that. They're not calculations, they're like logic. Next question.
Okay, so for the upper fence, it's a Q3 plus 1.5 times the interquartile range.
Yep.
Okay.
And what do we use the upper fence for?
Find outliers.
Correct. So let me put a story in. Let's suppose that we've already done our 5-figure summary, right? And the maximum number, right, was 82, right? And let's say Q3 was 50. And let's say that the interquartile range, which you do not get in the 5-figure summary, don't you have to calculate it yourself? Do you remember what the calculation for an interquartile range was? What do you do?
Q3 minus Q1.
You got it. Okay. So can we pretend that Q1 was 27, just for argument's sake? So we would get 23. So the upper fence is going to be Q3, which is 50, add 1.5 interquartile ranges, which is 23. So that's 50 plus 34.5, which is 84.5. And our question was this 82-year-old an outlier? Well, what is the conclusion? Is 82 an outlier now that you know that the upper fence is 84.5? Anyone want to throw in the answer? Is 82 an outlier when you know the upper fence is 84.5? Correct. It's not an outlier. Don't you have to be bigger than this guy to be an outlier? So this would not be an outlier. Let's suppose that there was a 92-year-old, right? Let's just say that, you know, the same data, but the maximum was 92. Would a 92-year-old be considered an outlier? Yeah. And don't we have a lower fence for outliers that are very small numbers? What is the test for outliers when you use standard deviation?
3.
Right.
Yeah.
Right. So if I told you that the mean was 30 and that the standard deviation was, say, 20, and then I said to you, if someone got a score of 125, are they an outlier? You would have to say mean plus 3 standard deviations. So that would be 3 plus 3 lots of 20, which is adds up to 90. And yeah, that's definitely an outlier, isn't that? That's quite a significantly bigger. On the other hand, if this number was 87, it would not be an outlier. And you have a small version of the same thing, right? If you take away 3 standard deviations from the mean, that's the value that you've got. Now, those kind of questions work really well with multiple choice, because couldn't you get the question? The answer, yes, it's an outlier. No, it's not an outlier. Now it's kind of hard for me to think of 2 or 3 wrong answers. Third, you can't tell from the information. And the fourth one would be, I don't know. I can't think of a fourth one right now. That's why making multiple choice questions is so difficult. It's easy because there's one right answer. The hard part is to try and find 3 other answers that kind of make sense, even though they're wrong, right? 3 other choices. Okay, what we got next?
There's a question in the chat.
Oh, okay. I can't get to my chat easy. Is it something you could read to me quickly?
Sure. For chapter 12 test question 5, what is the process to find whether or not to use a 0.5 null hypothesis?
Whoa, that's a long question. Hold that thought. So I'm going to have to go out and find that question, I think. So did they mention what section it was in again?
It's the chapter 12 test question 5.
Okay, so that's I'll be test 9. Okay. And question 5 in test 9 coming up. Okay, let me go over and read this question. See if we can figure out what it's saying. A statistic class actively asks students to randomly pick a number from 1 to 10. Of the 180 students, 52 of them picked a 7. Carry out the 5-step significance test to determine if people similar to these students are more likely to pick the number. Right, the null hypothesis here is that P is equal to 0.1. And the alternate is that it's bigger than 0.1. So let me explain where the 0.1 came from. You have 10 choices, right? 1 to 10. And each one of them is just as likely as any of the others. So there's a 1 in 10 chance that you pick a number. And 1 in 10 is 0.1. Now, the question mentioned, when would it be 0.5, right? 0.5 would come up with stories where you were looking at some election. Is the guy going to win the election? Is the majority of people in favor of something, right? Those kind of questions, P equals 0.5 is right in the middle. And then greater than 0.5 means majority, right? They're going to win the election or more than the people. So the 0.5s really only need to take place in those questions where things like that happen. Now, if you've got a physical story attached to it, in this case, 10 random digits, then the null hypothesis is, what in this case, what's the probability that you get that? Now, I could change this story and make it a 0.5 by saying, look, you get people to pick randomly 10 numbers, right? And I think people pick even numbers more often than they pick odd numbers. Well, P would be 0.5, right? Half of them are even, half of them are odd, right? P would be 0.5. And I think they're going to do more. So P greater than 0.5. So that would be how that story would work. So I hope that's me answered the question. I hope it is at least. Are we good? We're good, but is the person who asked it good? Because again,
River says
happy.
thank you. Yeah.
Okay. Right, next question.
Is it possible to look at the 5th question on the last test we just did?
It is possible because that last test is closed, so it's not like you can go in and change it. And sometime later today, I will go, as I always do, I will be going through those questions and tweaking them because WebAssign is not very friendly. So did you say question 5?
Yes.
Okay, so I'll put that on the share screen thing. Oh, I already was in share screen. Right, suppose that we have a 1 sample t-test. So the first thing you want to look here is any clues. Do you see that that t-test means I'm going to be using t-test, not z-scores, right? So I know it's t's, not right, t-distributions, not normal distributions. Now, in this story, H naught is the mean is 0. And the alternate is that it is not equal to. Do you see it? Not equal to. And they have a t-score. And they have a degrees of freedom. Oh, I recognize this one, Maggie. And that guy. Okay. Now, it says here, use technology to find the p-value in the original study. So the original study was these guys. And a not equals to. So I'm going to write that down. So I know T is 0.69. And I know the degrees of freedom were 13. And I know that it's a not equal to story. Okay. So I'm now going to hit use salt. And I'm going to go here and make it a T distribution. I'm going to put in the degrees of freedom, which they said was 13. Now, they told us in this story what the t-score was and that it was not equals to. So both tails is what you do with a not equals to. And then you put in negative 0.69, the t-score. And in the other side, you put the positive 0.69. And there you go. That is the p-value. And of course, my question has disappeared, but that would have been the p-value, right? Now, if they changed the story and they made it, I don't know, 140 people, that would be a p-value of one, that would be 139, right? So if you made degrees of freedom 139, right? There's your guy. Oh, what happened? Oh, that's a pain. Can you still see me, guys? Because some things disappeared here, like crashed. Can you hear me? Wave?
Yes.
Okay, so I'm still here, but everything else is gone. I don't know what killed it, but it killed it. I'm going to have to go in and redo something. So if you can bear with me for a few minutes, hopefully it'll just let me back in. So what are you seeing right now? Just me talking?
Well, right now we can see your Zoom screen.
Well, shut your eyes, everybody. Okay, launch meeting, open Zoom meeting. No good. I can't get in that way. Okay, how am I going to do this? I am going to.
I can still see you in the like participants, and you're sharing your screen.
Yeah, but unfortunately, I can't get back to my whiteboard, and
Oh.
that's kind of important. I'm going to leave for a minute, guys, and close my computer down and set it all up again. So while I'm gone, Brandy is going to answer all your questions, and Isabella's going to verify that our answers are correct. Okay, guys? So until I figure that out, Maggie's just happy I didn't pick her. So, okay, how am I going to, I think I'm just going to, I can't actually even get out of that window. Okay, so I'm going to have to do this, which is a bit severe. I'm going to go into here.
Is when you have to compute an approximate 95%. Is that where you take the p hat plus or minus the CM, the margin of error, conservative margin of error? Oh, you left on.
I am back. We are good. And let me see if I can go to my white screen. Brandy, did you answer any questions while I was gone?
Yeah, we're all gonna ace the final. We're good.
Wow, you. Well done. You did a good job. Okay, I'm ready for next question now.
Okay, so when you have to compute an approximate 95%,
Mm-hmm.
is that just p hat plus or minus the conservative margin of error?
Depends on the question. So let me give you some examples of how that would work.
Well, here in my notes, I have n equals 250, p hat equals 0.21 or 21%. And then I did conservative margin of error, which is 1 divided by the square root of 250,
That's good.
which is 0.06.
Okay.
And then I just did 21 plus or minus the 6.
Correct. So in in that context, in the question you've just given, you would do 0.21 plus or minus 0.06, which is 15 up to 27, right? Now, if it's not a conservative margin of error, but just an approximate 95, right? You can get that as well. So let's suppose we did p hat again. Couldn't we get the standard error of p hat? And then a 95% confidence interval is p hat plus or minus 2 standard error of p hats. Do you remember that formula is 95?
Yeah, what chapter is that on? That's further on.
Yeah, probably is. And what would one standard deviation get you? And lastly, what would 3 get you? Which this is sometimes called the empirical rule.
Yeah, it's I just wrote that down. 68, 95, and 99.7.
So I'm just be aware that it depends on the exact phrasing of the question, right? So if you got a question that asked you to find the conservative margin of error first, then this would be the way to go. If you were given a question that just finds approximate 95% confidence interval, and there was no mention of, you know, this guy, then you're more likely to be dealing with this. In fact, I would think these questions are more common than that kind. Okay. Hopefully that clears it up a little bit. I mean, if you did this one with that one, it wouldn't be that they would be miles apart. They'd be quite similar, but they won't be the same. You know, the numbers will, I don't know, 14 to 28, that kind of thing might happen.
I was just trying to do, since you said the test is in order from chapters.
Yeah, if that happened in a place that was coming later on, then that would be a good clue that you'd still be on this one. But then this one, well, I don't know if this one asked you to find the conservative margin of error or not. It may or may not have in the question.
Well,
Hopefully
I'm just on chapter 3, patterns and scatter plots, and I'm just trying to do.
Yeah. Well, yes, it's a short answer. You'd still be in here at that point. Later
Yeah.
on, we went on to this stuff. So, yeah. Okay, next question. That would work well, actually, in a multiple choice situation. It's
I
pretty
have
short.
kind of a
Mhm.
silly question. How do you turn a decimal into a fraction on your calculator again?
Okay, so let's suppose I had 3 divided by 8, right? So I'm only doing that so I can get a decimal, right? So I've got a decimal. You hit the math button, choice 1, and enter. So if you had 0.12 and you wanted to know what the fraction was, math button, turn me into a fraction, enter. So that would be 3/25.
Thank you.
Calculator's a great little gizmo, isn't it? Saves a whole load of, you know, fiddly stuff that you really don't want to spend a lot of time on. How are we doing? Any more questions? Are we getting to that point where you've asked what you want to ask? Remember, this is open-ended. You can leave when you want. I don't want to, you know, your time's valuable. I don't want to waste it for you.
I feel like I was having trouble with the null and the alternative hypothesis with the single means and the difference of 2 means, and I kept putting 0. Like mu1 minus mu2 equals 0, or just mu1 equals 0.
Right. Okay, let me try and show you the difference. Let's pick that one first, because they're easier. When you are doing a hypothesis test, and you're considering the difference in two means, your null hypothesis is always going to be that the difference is zero, because your null hypothesis is basically saying they're both the same, right? There's nothing to see here, right? They're both means are the same. And then your alternate hypothesis will be mu1 take away mu2, and it will either be, are you trying to prove that the first one's bigger than the second, that the first one is less than the second, or that they're just not the same as each other, right? The usual classic 3 directions to go.
No matter what, it's bigger, less, or greater than 0 or equal to 0.
Yeah, 0, 0 everywhere, right? No other numbers, at least in the questions you're going to see, right?
Oh, a single means it's not 0, right? It's the
Typically, you're correct. Almost every time it's not going to be. So suppose the null hypothesis, we don't even need a 1 there. The null hypothesis is that the IQ of Scottish people is 75 because they drink too much. And the alternate then would be, we think it is bigger than 75. We think they're even dumber, it's less than 75. Or we think it's just different from 70. Oops, put a 0 in there. It's different from 75. You see that they always have a number, right? And that number will be in the story. Like in the past, IQ of Scottish people was 75, right? Last year, the average score in my exam was 42, right? The percentage of Americans who drink too much is 42%, right? It's going to be a number, right? A 0.412 in that last case because it's a proportion. But the same thing works when you do proportions. When you're doing comparing two proportions, don't you just have P1? Oh, not again. I think it's Chloe. Is she hiding back there somewhere? I think it's my puppy playing about with the wires. I just can't see her right now. Right, P1 to P2 equals 0. And then your alternate is the first one is bigger than the second, or the first one is less than the second, or that they're just different from each other. And when you do a single proportion, you have, oh, the percentage of Americans who smoke was 32%. We think it's actually going up, or we think it's now less than that, or we think it's somehow different, right? It could be bigger, less. All I know for sure is that it's changed. Do you notice that when you see them together like that, isn't there a very big similarity about the structure? Right? The difference is 0 or one of these three. The difference is 0 or one of these. So when it's testing the difference between everybody, do you notice everything's zeros? But when it's testing a single proportion, or over here a single mean, do you see it's always going to be, this is what it used to be, and now we want to see if it's changed, bigger, less, or just different. Make sense? And once you know that, isn't salt your friend? Now,
yeah, you could actually bookmark salt under your, like your home screen on your web, so you don't have to find a random question. You could just bookmark the salt so you can just go straight to
I
it.
don't know how to do that. I don't know if it's possible, but what I did do, and you might have noticed it in your homework, is that it looks like a homework question, but I can't remember what its name is. Actually, I've got enough time. I should be able to find it and show you. This is how you're going to get to salt for all those different questions in your final, where salt is going to be your go-to guy, right? So if you hang on a few moments while I find it. Here we go. I've got it now. Oh, shooting space. Why can't I see it? There, try it again. There we go. Do you see this guy down at the bottom? Questions to be used in final exam question. God, that's horrible grammar, but you know what I'm getting at. Probably take one of those out.
So I'm saying if you go to a random question and then you go on salt and then you see the three little dots up on the top right of your screen where the D is and then the three little dots.
Oh, okay, let me, I've just saved that and I'm not good at multitasking, so I'm listening. What you were saying?
Okay, so if you're in salt, right?
Okay, so let me pick this one. Here we go. Right, what do I do now?
Okay, now go to salt.
Oh, I got some.
Okay, now see on the top right of your screen, the three little dots by the D, the purple D. Yeah, click that.
Uh-huh.
Okay, and then go to bookmarks.
Oh, you just want me to save this page.
Yeah, I'm just saying you could save salt onto your tab so you don't have to go to that. You can just go to the salt. I was just
Okay, that works.
a little shortcut for people.
That works. So when you've got when you're doing your final, you'll whatever way you end up doing it, aren't you going to have this salt button? Now, no attention at all to this. It's just a random salt question, right? A question. So what you will be doing is inferential statistics. Won't you type in your stuff? Or if you're wanting to do descriptive statistics, well, you probably won't you do that with your calculator, but inferential for sure. Oh, and distribution, right? They would be the two major ones that you would be using it for, right? You'd use this for all your hypothesis tests, agreed? Actually, and your confidence intervals, right? So that's going to be a biggie. And this one you occasionally use as well. So that's what that was there for. It's just a random question, only because it had a salt button on it. So don't pay any attention to that question. Just use it to hit the salt button. And if we do what Cody was suggesting, can I save it inside the salt? Can I try that? Let me see. Right, so that's me in here. I'll go up here. I'll bookmark it. Bookmark what? Bookmark this tab. Call it salt. Well, not putting it there. That's all the stuff I put for retiring. What else folders can I have? Online's a good folder. I put it in there. Right, so if this works, I should be able to go here and click on that. You know, it's hard to tell because it looks just like it did. So if I close that off and then I go here and I go, in my case, online, and I click on that guy. Hey, now we've got salt. That's a cool thing. Yeah, Cody.
That's cool.
Doesn't it work so?
I didn't know you could make bookmark folders.
Oh, well, you learned something as well. Well, you know, do it that way, you know, or, you know, you could practice it. Couldn't you go in right now, make a tab for it and it's there? And that way, every time you need the question, just hit the tab and you're into salt. And it's kind of cleaner that, isn't it? Because it doesn't have all those numbers and stuff to clutter your brain up because you don't actually need that stuff. You only need this. I like learning stuff. So I learned I can bookmark salt.
Would you have to sign in every time you open the bookmark though, since it's
Oh, I don't know.
website?
Yeah, I don't know. I haven't. I'm already in salt in WebAssign. That's a possibility.
You don't
I don't know.
have to.
Well, yeah, but once you're in, right? You don't need to do it anymore. So that's not a big deal if you do have to do it. I think it's still worth it.
You don't have to re-sign in or nothing. Once it's bookmarked, you can just click on it and it'll go straight to it.
Well, that's what Cody is saying. I don't know yet. You'll find out. Why don't you find out and then, you know, that's great. And if you have to sign in, that's still okay. Right, what's next?
I
I-
have a quick question. Would you mind going over question 13 on the practice final?
Question 13. Let me find it first. Come on. 146. Practice final. Gotcha. Number 13. Is that 13 in the multiple choice or 13
The
in the
written.
the written? So it's the longer questions, right?
Yes.
Right. Slowly getting there. I think I'm at it. No, missed it. Okay. So here we go. Try and make this a little bit bigger so everybody can just be, familiarize ourselves with that. Are you looking at my white page or are you looking at the question itself?
The question.
Oh, good. So I don't need to go out and in. Okay, so suppose you know that 20% of Americans smoke and a sample of 400 people is taken. Are the conditions of a sampling distribution to be normal in shape met? Right. So we're assuming that you took a random sample and that 400 is big enough. Now, actually, the test for 400 to be big enough is actually called the 10 test. So what you would do is 400 times 0.2 and 400 times 0.8, right? The P and the 1 minus P. And they have to be bigger than or equal to 10. So yes, the conditions are met. And then it says, construct these guys. Do you recognize those numbers are very, very specific? Isn't that 1, 2, and 3 standard errors away from the mean? So I'm going to write those numbers down and move on to my white screen. Right. So let's create those 3 confidence intervals for the percentage of Americans who smoke. Right. So we were told that it was 20%. So write that again. We were told it was 20%. And so the standard error is the square root of P, 1 minus P over N. And we were told that N was 400. So it's going to be 0.2, take that away from 1, 0.8, and divided by 400. So on my calculator, that becomes the square root of 0.2 times 0.8 divided by 400. And the answer I have is 0.02, which is a nice guy to work with. So if you want a 68, it's P plus or minus a standard error. If you want a 95, it's P plus or minus 2 standard errors. And if you want a 99.7, our estimate would be P plus or minus 3 standard errors. In this case, 0.2 plus or minus that guy, 0.2 plus or minus that guy, and 0.2 plus or minus that guy. And in this interval, it could be as low as 18, or it could be as high as 22. In this case, it could be as low as 16, but it also could be as high as 24. And this one, it could be as low as 14, but it might be as high as 26. And we have now constructed all the confidence intervals, right? Now, what we're going to do now is it says what percentage of the sample would be 26 or less. And I'm going to do our empirical row. So I'm going to draw a little picture. Right in the middle is 0.2. And then 1, 2, 3 standard deviations. That gives me 22, 24, 26. Okay. And then 1, 2, 3 go on the other side. So just for completeness, 18, 16, 14. And we're being asked that, right? We're being asked less than 26%. Now, we're not doing this with salt, we're doing this using the empirical rule. And we already know that from here to here, right, that distance from there to there, which is this one here, right, is 99.7% of all the data is going to be in that range. Great. Now, that means there's a little bit still unaccounted for. Would you agree that the little bit is 0.3%? And isn't that little bit shared equally on both sides? And half of that then is 0.15, and that's him. And if you wanted to, but I don't, the other side. Now, if you go here and everybody, including that little bit, is 99.7, right? And you add what's left here, there's a little 0.15 here. So I'm just saying our answer is 100 minus that tiny little piece. And so it's 99.85%. Almost guaranteed, isn't it, that you're going to get an answer less than 26%. Now, in the next one, it says 14 to 24. So I'll draw my picture again. And there's the middle. And we have 1, little dotted line, 2, 3. There's 14 here. (22), 24, 26. My little dotted lines going in here. And we want to know between 14 to 24%. So I want this piece, this piece, this piece, this piece, and this piece. And I need to find what all of this is. And that's going to be my answer, right? I need to find out what percentage is from here to here. And you can tackle that all sorts of different ways, right? And could I find out how much that little piece is, how much that little piece is, and how much that little piece is, and take it away from 100? That would work totally fine. Couldn't I find out how much each of the 5 pieces are and just add them up? That's totally fine. Couldn't I find out what those 4 pieces are and just add that little piece there? That would work. I'm going to try it that third way. If you go from here to here, that's essentially 2 standard deviations either side of the mean. Agreed? And that is 95%. So I already know what these 4 pieces add up to. They add up to 95%. So all I need to do is find out how much that little piece is and add it on, and we're done. Now, okay, I could find that another way. I've already found out how much that little piece is. Remember, it was the 0.15% guy. Right. So I'm going to cover all of that up. Would you agree that there's 50% going this way? Now, we know that from here to here must be 50%. And so what's left from here to here, right, all these three pieces, would be the other 49.85%. Oh God, I'm taking a meal of this. It's a lot quicker than that. Well, okay then. So I've changed my process. I've now found these three guys add up to 49.85%. And I can find these two guys and I would be done. And I have made a mess of this. So are you going to pretend, because I changed my mind halfway through how I was going to do this. And then I ended up finding something I didn't want to find. So this is version number 2, the cleaner version. I'm going to start off the way I said before. I already know this is 95%. So all my goal now is to find that extra little bit. So from here to here is 99.7%. Since this is 95 and this is 99.7, if you take 95 away from 99.7, the other 4.7% comes from the extra bits. If you divide them by 2, you get 2.35%. There we go. That guy there is 2.35%. This bit here is 95. My answer is 95 plus 2.35 for that extra little piece. And that is 97.35%. As I say, I made a bit of a meal of that. Actually, the way I was going here would have eventually worked. And what I was eventually going to do is find out how much every single one of them was and add them all up, which would have worked, but it would have been a lot more work to do it. Are we comfortable with that? It's all about an analogy. I think of this as being a cake, and you're trying to cut it into bits, and then you want to find out how much cake do you get, right? And each piece of the cake is worth like 30% or 0.15% or whatever it is. And if you add them all up, that's what you're going to get.